Hey Algebra 3, what we're going to be doing in this video is sections 3.4 and 3.5. We're going to start out with 3.4 and we're going to learn about slope-intercept form of a linear equation. Then we're going to get into the next section where we learn more about the slope-intercept form of a linear equation, but we're going to be doing things with the slope and determining lines parallel and perpendicular to each other. Okay, so like I said, they coincide with each other quite a bit. So we'll go ahead and we'll get started on this. Alright, first thing we're going to look at is slope. If you remember way back when you were in Algebra 1, you would remember that slope is the rise over the run, meaning you rise up from one point and you run over to the next point. So you go up and then to the right for your slope. And then another way of looking at it, other than the rise of the run, is it's the change in y over the change in x. Change in means the two y values that you know in your points that you're given here, subtracted, and then over the two x values, subtracted. So let's look at this right here and find the slope that if I drew the line in here between these points, what would be the slope of this line? So looking at points 3, 6, and 1, 2, we would have m equals 6 minus 2 over 3 minus 1, which equals 4 over 2, which equals 2. And there's our slope. And we're going to be doing some more of this. Okay, here's something that I could ask you about your equations of your lines. I could ask if your slopes are positive or negative, and here's how you're going to determine that. So a positive slope, if you're reading your graph from left to right, is always going to be going up. And then again, reading your graph from left to right, for a negative slope, your graph is always going to be going downwards. So those are simple enough. Just remember you have to read your graphs from left to right in order to figure out whether you have a positive or a negative slope. Okay, like in the last section, we learned about horizontal lines and vertical lines. A horizontal line always has the slope of 0. So for example, this equation right here, we have y equals 2. And that's just going to be a horizontal line, no slope at all, at y equals 2. And there you go. And then a vertical line, the slope of it is called undefined, because this right here is not a function. Wouldn't pass the vertical line test because it is a vertical line. But a vertical line would look like this right here. It's just a vertical line at your x value, okay? And our x value here is -4. You see that? And so x equals -4 would be your vertical line for this equation. Now we're going to look at slope-intercept form of an equation, and that is this right here, y equals mx plus b. M right here represents our slope. The b here represents our y-intercept. So looking at these two examples here, let's determine the slope and the y-intercept. And if it's in this form right here, then it should be pretty easy to tell what is what. So the number that is being multiplied to your x value, that is always going to be your slope. and then the constant number that is out here, and you take the sign with it, whether it's positive or negative, that is your y-intercept. So b equals -4. Okay, let's do that again. The number being multiplied to x, that is your slope. So that's 2/3. And the number being added or subtracted is your y-intercept. So positive 1/3. And we are done with that. So now we are asked to write the equation you see here in slope-intercept form. So that's in the y equals mx plus b form, slope-intercept, okay? Write it in, oh, that's a terrible y, there we go. Y equals mx plus b, slope-intercept form. That's where the name comes from. Okay, so what we need to do to solve, to write this equation in slope-intercept form is solve for y. And once you get y in terms of x, you're done. What I'm going to do here is subtract 7 from both sides. So we get 6x minus 7 equals 8y. Now, to get rid of y and not to do this right here, divide everything by 8, what I'm going to say is, write it a little bit different, but same thing. Divide everything by 8. Okay? Because that's doing the same exact thing as what if you divided it all over 8. Alright, so that gets rid of that on that side. And your y equals, reduce this fraction. That is going to be 3/4 x minus 7/8. And we are done. That equation is in slope-intercept form. Okay, so the point-slope form of a linear equation, see, this ties straight into the previous section. Alright, this slide is very useful in helping us figuring out different equations of lines, especially if we have the slope of a given line and then we are also given a point. A point will be represented by an x value and a y value. And we just plug those in, and when we solve for y, we've got it in our slope-intercept form. And we've got our equation. So that's what we're going to do here with this example. We're going to be using the point-slope form to figure out what our equation of our line is in slope-intercept form. Okay? So, using the point-slope form of our equation, we're going to say y minus y1, which is 3, equals our slope, which is 4, times x minus x1, which is 2. So our point is always going to go in for x1 and y1. We're never going to put anything in for y and x, okay? Because we need those variables for our equation. So distribute the 4 and add 3 to both sides. We end up getting y equals 4x minus 5. And we're done. So this point-slope form is very useful to memorize. Alright, parallel lines and perpendicular lines is what this section is mainly about and what I want you to understand from it. If you remember from geometry, parallel lines, they're never going to intersect. And Also, something about parallel lines that you may remember from Algebra 1 is that they have the same slope. Okay, so the slope from this equation of a line is going to be the same exact slope for this equation of the line if they are parallel to each other. If they just intersect each other, you don't know what the slopes are related to each other. But let's look at perpendicular. Okay, if they're perpendicular to each other, meaning they intersect each other at a right angle, what goes on with the slope is the slope of your one equation of your line is going to be equal to the negative reciprocal for your other one. So say you have the slope of 2 as one of your lines. The equation of the line that is perpendicular to this is going to have a slope of 1 over that, or you're just going to say 2 over 1. If you flip that, that's the reciprocal, is flipping the fraction. And then you place a negative sign in front. So the negative reciprocal. Flip the fraction and put a negative in front of it. If you already had a negative in front of it, then it's going to change it to a positive. Say this was negative 2, and this is going to be positive 1/2. Okay, so we're going to use these two facts about parallel lines and their slopes, and then perpendicular lines and what their slopes are, to help us in figuring out whether two lines are parallel or perpendicular or neither. So that's what I ask here. Are these two equations parallel, perpendicular, or neither? And the quickest way to go about doing this is solve for y and each. Put it in the slope-intercept form, and you'll have your slope. Look at the slopes of both of them. If they're equal, then they're parallel. If they're not equal, check to see if they are negative reciprocals of each other, and that means they're perpendicular. So let's look at this one. Okay, from here, what I'm going to get is 2y equals negative 4x plus 8. Divide everything by 2, and we get negative 2x plus 4. Okay, so our slope from this line right here, we're going to call it, undo. We're going to call this our M1 equals negative 2. Now let's see if the slope of the second line is also negative 2, or a negative reciprocal of that number. So here, let's solve for, again, y equals, so here I'm going to get 8 x minus 4 equals 4y. And then divide everything by 4, we get negative 2x minus 1. Oops, that's supposed to be a negative. Plus 1 equals y. And here we go again. See, just like we got the slope of this one is negative 2, well, the slope of this one is also negative 2. This means they are parallel because the slopes are equal. Now let's do the same thing. Well, we've already got this line, in slope-intercept form. Here is our slope for our first equation. Say it's 1/2. Now we're either looking for the slope of our second equation right here. We're looking for that to either be -1/2, so we can show that they're parallel, or we're looking for it to be, if we were to flip this fraction up, and then place the negative in front of it, it would end up being -2. So let's see if it's equal to this slope or if it's -2, and then it's perpendicular. Alright, so solve for y. Well, that's not too bad in this one. Divide everything by -4. And we get y equals -2x minus 15/4. Well, we found that this slope here is -2, and that's what we're looking for, either 1/2 or -2. That means these lines are perpendicular to each other. Okay, there we go. Now, if they actually ended up being like one of them had a slope of 1/2 and the other one had a slope of, say, +2, well, then they would be nothing to each other. They wouldn't be parallel and they wouldn't be perpendicular. Now, let's look at this right here. We're going to have a few of, maybe quite a few of these in your homework to solve that are very similar to this right here. We're asked to consider this equation that we're given and determine an equation of a line that passes through a given point and is parallel to this given line that we have, and then also perpendicular to it. So remember, parallel means same slope, perpendicular means negative reciprocal. So the first step in parts A and B is to find the slopes of our equations that we're going to come up with. So for part A, we need the same slope. And then part B, we need the negative reciprocal. Okay, so solve for y to figure out the slope. And then once you get that, I'm going to divide everything by 3. We are good because we have our slope now. There we go. Our slope is 2/3. So for the line that passes through 6, 1 and is parallel to this given equation, what we're going to do is keep our same slope. And then for perpendicular, our slope is going to be negative reciprocal, so 3/2. Alright, so let's use our point slope form because we are given a point and we have our slope of our equation. So I'm going to write it out again. Okay. Now plug everything in. And solve for y now. So distribute. So now we need to completely solve for y, subtract or add 1 to both sides. And we get that. So this line is parallel to the other one, and it goes through the point 6, 1. Now, let's use the same point and this new slope right here, this perpendicular one, to find out the equation of that line. So we know the measure, or the slope is -3/2, and our point is this. So y minus y1 equals slope times x minus x1, using that point slope formula. Plug in everything you know. Distribute. Let's see, that's going to be 3 times 3, which is 9. Subtract, sorry, that's going to be a plus sign. Add 1 to both sides. We get y equals -3/2 x plus 10. And we are done. Okay, so that is the gist of what these two sections are about, and I will see you in class. Goodbye, everybody.